Hello students and welcome to my channel Maths Hub. So in my last video I was talking about the shortest path algorithm and we discussed about the Dutch-Cartwright algorithm. So in today's video I'll talk about the Warshall's algorithm. So let us start with the history of this algorithm and then we will go into the process how do we apply this algorithm in the questions, right? So this algorithm is also known as the Floyd-Warshall algorithm, and it is a famous algorithm that is used to solve the all-pair shortest path problem, right? That means what is the difference in the Dutch-Cartwright algorithm and in this algorithm is that the major difference is that in Dutch-Cartwright algorithm, we are always given a source vertex from where we have to start making the shortest path, right? But in Warshall's algorithm, you can find the shortest path from every vertex to the every other vertex, right? So there is no characterization of a source vertex here. So from every vertex to any other vertex in the graph, you can always find the shortest path using the Warshall's algorithm. But in Dishkartra's algorithm, every time a source vertex is always mentioned from where we have to start calculating the shortest path, right? So it computes the shortest distance between every pair of vertices of the given graph. So this is a major difference in these two algorithms. Now, how does this algorithm work? So what are the rules for the first weight matrix? So here what we are going to do, in every step we are going to develop a weight matrix, and that weight matrix, how it is developed, there are certain steps. So in this you will always find that the graph will always have weights. If the two vertices are same, then the weight will be 0. If the two vertices are different from each other, that means the indices I and j are different. So it will have certain weight wij. And if there is no connectivity between I and j, then the weight stands as infinity. So here wij is the distance between the vertices in matrix at ith row and jth column. And wij is the weight of the edges between the vertices. And here E represents the set of edges, right? So 0 denotes it's those weights where the indices I and j are always equal. The index when I is not equal to j, then we will have the weight wij. And when that vertex, that edge is not there in the edge set, then that weight will be infinity, right? So these are the rules for the first weighted matrix, and these are how the weights are going to be there. So the weights can be either 0, there can be some finite weight, or the weight can be infinite, right? Now, how do we go about how, so we get the first weight matrix, and then from the first weight matrix, how do we go to the next weight matrix? So the entries in the weight matrix are given by these formula. So the distance ij at the kth weight matrix, it is always equal to minimum of dij between the weights in the previous matrix, or if there is a middle path, that means if I and j is connected with the middle path k, so we have to check what is the distance of dik plus dkj, right? So out of the two distances, we need to choose the minimum of the two distances, right? So just note down this formula dijk. K is the kth weight matrix. So if we are going for the first weight matrix, k will stand out to be 1. It is minimum of dij k minus 1, comma dik k minus 1 plus dkj k minus 1, right? So we will be repeatedly using this formula to calculate the entries in the weight matrix, right? And then we will initialize, we will improve our weight matrix unless and until all the weights are improved, and when we get the final weight matrix where all the infinities are removed from the weight matrix and all the weights have been improved, that will be declared as the final weight matrix, right? And from that weight matrix we can get the shortest path from every vertex to every other vertex, right? So let us see how this Warshall's algorithm works. So we have to find out the shortest path, all pair shortest path by the Warshall's algorithm for this question, right? So how to go about it? Let's see. So first of all, let us see this matrix, see this graph, and let us develop the first weight matrix, that is Q naught. Now what is the weight matrix Q naught? Now the weight matrix Q naught, it is just similar to an adjacency matrix, but in adjacency matrix the entries are 1 and 0, but here we are going to enter the weights of the vertices. So you can see that we have vertex 1, vertex 2, so we are going to write the vertices in the rows and we are going to write the vertices in the columns also, right? 1, 2, 3 and 4. And now let us write down the entries in this weight matrix. So I told you, as I showed you the weight matrix, if the indices are same, 1 is equal to 1, so the weight is 0. So you can see there is no edge connecting 1 with 1, right? Now, 1 with 2, is there any edge connecting 1 with 2? Yes, and the weight is 8. So we'll write 8 over here. 1 with 3, is there any edge connecting 1 with 3? No. Sorry. So if that edge is not in the edge list, we will put infinity there, right? Then is 1 connected with 4? Yes, 1 is connected with 4 and the weight is 1. Next, 2 with 1. Is 2 connected with 1? No. So the weight is infinity. Is 2 connected with 2? No. The indices are same, so the entry is 0. 2 with 3, the entry is 1. 2 with 4, you can see that there is no edge, so we'll write infinity here. Next is 3, 1. 3 with 1, yes, 3 is connected with 1 and the weight is 4. 3 with 2, there is no edge, so infinity. 3 with 3, we will put 0. 3 with 4, is 3 connected with 4? No. So again, we will put an infinity over here. 4 with 1, is 4 connected with 1? No. So we will put infinity over here. 4 with 2, is 4 connected with 2? Yes. So we'll write 2 over here. Is 4 connected with 3? 4 is connected with 3 and the weight is 9. 4 with 4, the entry is 0. So you will see that all the diagonals are 0 and wherever the two indices are not forming an edge, we have put an infinity. So we need to improve this weight matrix. So how will I get the matrix Q1? And in Q1, which entries are going to change? Now when we talk about Q0, what we are going to do, we will be, I'll just mark this. So in Q, what will happen? So in Q, we are going to all these entries, the first entries, right? We are not going to change these entries when we are writing the first weight matrix, right? So when we are writing the first weight matrix, the first row and the first column will remain unchanged. So these entries are going to change, right? So let us find out the first entry. So if I recall the formula, let me write down the formula over here. Bij K. That means the distances in the new weight matrix, it is minimum of Dij K minus 1. So in the previous matrix, comma, Dik K minus 1 plus Dkj K minus 1. So with the help of this formula, we are going to calculate all these distances. So let us calculate the distance. Now 2 will always remain 0 only. So let's calculate 2, 3. So this is the first entry that we are going to calculate. So what is, so let me write it over here. So D23 in the first weight matrix, Q1, we are talking about Q1. So it is minimum of, according to the formula, it will be D23 in the previous matrix, comma, D2, what is K here? K is 1. So D21 in the previous matrix plus D13 in the previous matrix, right? So let us list down what is the values of these. What is D23 in the previous matrix? D23 is 1. And what is D21? D21 is infinity plus what is D13? D13 is also infinity. So infinity plus infinity will be infinity. So what is minimum of 1 and infinity? It is 1, right? That means when we will write the entries in Q1, so let me write 1 over here, 2 over here, 3 over here and 4 over here. Similarly 1, 2, 3 and 4. So as I told you that the first row and the first column will remain same. 0, 8, infinity, 1. Similarly infinity, 4 and infinity, they will remain same. These entries will remain same. 0, 0, 0. So the first entry that we have improved is 1 remains 1 itself. Right? Now let us calculate the next entry, that is D24. So now what is D24? D24 in the new matrix 1, it is minimum of, take care of these indices and let's see, it is D24 in the previous matrix, comma, D2k is 1 in the previous matrix plus D14 in the previous. So this is minimum of, what is D24? D24 is infinity. D21, D21 is infinity plus D14. D14 is 1. Right? So infinity plus 1 is infinity. So minimum of infinity and infinity is infinity. That means this place remains same. We have infinity only. Now let us calculate the next place, that is D32. What is D32? D321. This is minimum of D32 in the previous weighted matrix, then D31 in the previous matrix plus D12 in the previous matrix, right? So now this is minimum of, what is D32? D32 is infinity. What is D31? D31 is 4 plus D12. D12 is 8, right? So you can see we are getting 12 over here. So minimum of infinity and 12 will become 12, right? So you can see that the first entry is getting improved from infinity. We are getting 12, right? Now let us calculate the next entry, that is D34. Now what is D34? D34 in the new matrix will be minimum of D34 in the previous one, then D31 in the previous one plus D14 in the previous one. So how much is this? This is minimum of D34 is infinity, D31 is 4, D14 is 1. So you can see that the entry comes out to be 5. You can see that this entry is also improved. It is 5 now, right? And then we go to the next one, that is D4, 2. So I'm just rubbing off this portion. And let us calculate what do we get here. So now we are calculating D4, 2. What is D4, 2? It is minimum of D4, 2 in the previous matrix, comma, D4, 1 in the previous matrix and D1, 2 in the previous matrix. So how much is D4, 2? D4, 2 is 2. D4, 1 is infinity plus D1, 2. D1, 2 is 8. So infinity plus 8 will be infinity. So minimum of 2 and infinity is 2. You can see that the entry remains same, 2 over here. And then finally let's calculate the last entry, that is D43. So I'm rubbing off this portion. So what is D43 now? D43 is D43 in the previous one, comma, D41 and plus D13. So how much is D43? It is 9. D41 is infinity and D13. D13 is infinity. So you can see that the answer will be 9. So you can see that when we move from the initial matrix to the first weighted matrix, only 2 entries are getting improved, right? So still you can see infinity at many places. So we need to improve them. Now we have to develop the next weighted matrix, that is Q2. Now when we are developing the next weighted matrix, that is Q2, what will happen now? You will find that there will be no change in the matrix in the rows 2 and in column 2, right? When we moved from Q0 to Q1, we didn't change the first row and the first column. When we are moving from the first cell to the next cell, we will not be changing the second row and the second column, right? Okay. So now let us, okay, let me rewrite this entry as 8. Okay. So we will not be changing the second row, second column, and let us now develop Q2. So I'm just dropping off this matrix, right? And I'm also rubbing off this entire part, right? So that we can recalculate the rest of the entries. So you are supposed to do it with me so that even you don't face any doubts at the end, right? Okay. Okay. So now we will develop Q2 here, right? When we are developing Q2, first of all, the diagonal entries will remain same, right? 0. And the entries in the second row and the second column will remain same. So we have 12 here, 2 here, infinity here, 1 here, and infinity here. So let's calculate the rest of the entries, right? So let's calculate first of all D13 in the new weighted matrix now 2. So now this will be minimum of D13 in the previous one, comma D12 in the previous one plus D23 in the previous one, right? I hope you can understand how these places are changing. Now I and j are being played by 1 and 3 and k is playing the role of 2. So how much is this now? Minimum of D13 is, how much is D13 in the previous matrix? It is infinity. D12 is 8. D23 is 1. So you can see that the answer is 9. So we will write the answer 9 over here. Right? Now let us calculate the next one, that is D14 in the new matrix. So this is minimum of D14 in the previous matrix, comma D12 in the previous matrix plus D24 in the previous matrix. Right? So how much is this? This is minimum of D14 is 1. D12 is 8 plus D24 is infinity. So minimum of 1 and infinity will be 1. So the entry comes out to be 1 over here. Right? Next, let us calculate D. So you can see the second row is complete. D31 in the second weighted cell. So this is minimum of D31 in the previous one, comma D32 in the previous one plus D21 in the previous one, right? So how much is this? This is minimum of D31. D31 is 4 and D32 is 12 plus D21. D21 is infinity. So you can see that you will get 4 as your answer, right? And then we calculate D34. D34 in the new weighted matrix 2. So this is minimum of D34 in the previous one, D32 in the previous one plus D24 in the previous one. So how much is this? This is minimum of, what is D34? D34 is 5. D32 is 12 plus D24. 24 is infinity. So you will see that you'll get 5 over here, right? So you will see that not all places get improved every time, but some places get improved, right? And now we need to calculate D41 and D4. So let's calculate D41 in the new cell. So this is minimum of D41 in the previous one, D42 in the previous one plus D21 in the previous one, right? So this is minimum of, what is D41? D41 is infinity. What is D42? It is 2. And what is D21? It is infinity. So you will find that you will get infinity over here, right? And now the last place to get improved is D43. Let's calculate D43. D43 in the matrix 2 is minimum of D43 in the previous one, comma, D42 in the previous one plus D23 in the previous one. So how much is this? This is minimum of, what is D34? D43, sorry. D43 is 9. D42 is 2 plus D23 is 1. So you will get minimum of 9 and 3, that comes out to be 3. You will find that 9 has been improved to 3, right? So we get Q2, but still you can see that there are still 3 infinities. Now when we move from Q2 to Q3 to the next weighted matrix, now our third row and third column will remain the same, right? So now let us mark the third row and the third column similar. So we will mark the third row and the third column. And now let us improve Q2 and let us rewrite the entries of Q3, right? So I'm going to write now Q3 and you can see that 1 1 will remain 0. This is 4, this is 12, this is 0, this is 5, this is 1, not 1, sorry, 9, then we have 1, then we have 0 and then we have 3. So this entry is remaining same and this entry is remaining same. That means we have to find out all these entries, right? So to start with, let us write down the entries over here. So you have to repeat this process, right? Repeatedly. So let me just rub off this portion and then we will find out the new distances in the weighted, right? Okay. I hope you are getting these steps, right? Okay. So now let us write down the first one. The first entry that we need to calculate is D12. So what is D12 in the new matrix, that is 3? So it is D12 in the previous matrix 2, comma, D13 in the previous matrix 2 and D32 in the previous matrix 2. So how much is this? Distance of minimum of 1 2, distance 1 2 is 8, 1 3 is 9 plus 3 2 is 12. So obviously the minimum will be 8. So let us write down the entry 8 over here. Right. Next, Now we will calculate D14. D14 in the new matrix 3 is D14 in the previous matrix 2, D13 in the previous matrix 2, D34 in the previous matrix 2. Right? Now how much is D14? D14 is 1, D13 is 9 and D34 is 5. So the minimum distance is 1. Right? Then let's calculate D21. How much is D21 in the new weighted matrix 3? It is D21 in the previous matrix 2, D23 in the previous matrix 2, D31 in the previous matrix 2. So D21, how much is D21? D21 is infinity. D23, D23 is 1 and D31 is 4. So the minimum will come out to be 5 over here, right? Then let us calculate the next one, that is D24. How much is D24 in the new cell 3? It is D24 in the previous one, D23 in the previous one, D34 in the previous one. So what is D24? D24 is infinity. D23 is 1 plus D34 is 5. So your answer is 6 over here, right? Now let us calculate D41. How much is D41 in the new cell 3? It is D41 in the previous cell, D43 in the previous cell 2, and then we have D31 in the previous cell 2. So how much is D41? It is infinity. How much is D43? It is 3. How much is D31? It is 4. So your answer is 7. Right? And let us calculate the last one, that is D4 2 in the weighted cell 3. So it is D4 2 in the cell 2, D4 3 in the cell 2 plus D3 2 in the cell 2. How much is D4 2? D4 2 is 2, D4 3 is 3, D3 2 is 12. So your entry becomes 2 over here. Right? Now, can we further improve it? Yes, we can further improve it. So now what is left? Till now we have just done till the third row and the third column. So now we will be improving the last this, and now when we go from Q3 weighted cell to Q4 weighted cell, we will keep the entries of the fourth column and the fourth row same, and we will improve upon the rest of the, right? So we will change now all these cells and we will write the new column, the new weighted matrix, that is Q4, right? So now let us calculate from Q3 to Q4. So we will keep the entries in the diagonal 0 and we will keep the entries in the fourth column and the fourth row same. So we have 7 over here, 2 over here, 3 over here, 1, 6, 5 and 0, right? So the first entry that we will calculate is D12. What is D12 in the new weighted matrix 4? It is D12 in the previous one, then D14 in the previous one, and D42 in the previous one, right? Now how much is D12? D12 you can check, it is 8. What is D14? It is 1 plus how much is D42? It is 2. So you can see that the minimum out of them is 3. Right? Next, we calculate D13. What is D13 in the new weighted cell 4? It is D13 in the previous one, then D14 in the previous one, D43 in the previous cell. Now what is D13? D13 is 9. D14 is 1 plus D43. D43 is 3. So 9 and 1 plus 3 is 4. So the minimum is, right? Now let us calculate D21, D21 in the new weighted cell 4. So it is D21 in the previous cell 3, comma, D24 in the previous cell 3, D41 in the previous cell 3. So what is D21? D21 is 5. And what is D24? It is 6. What is D41? It is 7. So minimum of this will become 5 now, right? Okay, so you can see that some are getting improved and some are remaining the same. So now let us calculate D23. What is D23 in the new weighted cell 4? It is D23 in the previous one, D24 in the previous one, plus D43 in the previous one. Right? Now what is D23? D23 is 1. D24 is 6. D43 is 3. So the minimum comes out to be now 1. Right? Sorry, 1 over here. So we haven't calculated D31 yet. Right? So now let us calculate D31. Now what is D31 and D32? These are the two things we need to calculate. So D31 in the new weighted cell 4 is D31 in the previous cell 3, D34 in the previous cell 3, D41 in the previous cell 3. How much is D31 now? It is 4. How much is D34? It is 5. How much is D41? It is 7. So minimum will come out to be 4. Right? Similarly, let's calculate the last entry, that is D324. D324 will be D32 in the cell 3, D34 in the cell 3, D42 in the cell 3. So D32 will be coming out to be, D32 is how much? It is 12. D34 is 5 and D42 is 2. So minimum of 12 and 7 will come out to be 7. Right? So now this is the last weighted matrix that we get for this graph, and from this weighted matrix we can calculate the shortest distance between any vertex to any other vertex. Suppose we need to calculate the shortest distance between vertex 1 and vertex 4. What is the shortest distance? We'll go from 1 to 4 and the shortest distance is 1. So you can see that 1 to 4 can be covered with this weight 1. Similarly, if somebody asks you what is the shortest distance between 3 and 2? The shortest distance between 3 and 2 is 7. So how 3 and 2 is 7? So just search for it, how it is 7. Between 3 and 2, just check how it is 7. Can you see how it is 7? Yes. See, it is how it is 7. Between 3 and 2, go from 3 to 1, then go from 1 to 4, and then go from 4 to 2. So you can see 4 plus 1, 5 plus 2. So you can cover up any distance, any shortest path between any vertex to the any other vertex with the help of the last weighted matrix. Right? So I hope the algorithm is clear to everyone. You can see the steps again and again if you have any difficulty. And in the next slide, I've given you one more question to practice. So do practice that question. You may find the answer there in your slides, but do check it whether you are getting that answer or not. Right? Okay. So this is how I've solved it, and I've mentioned all the matrices in every step. Right? So we have calculated Q2, then Q3, and then we have calculated the final matrix Q3, and then from Q3 we have gone to Q4. So Q4 gives you the shortest distance between any vertex to any other vertex, right? And this is one exercise for you. So you need to calculate the shortest path in this graph between any pairs of vertices, and the answer is already given there in the slide. So do not check the answer first. Do practice them. I've given you the matrices so that you can check your answer towards the end. and you can cross verify your right. Okay. Thank you so much for listening to me. I hope you've understood the Warshall's algorithm. It is a little lengthy, but it is not that difficult, right? So if you like the video, do hit the like button. And those of you who have not subscribed my channel, do subscribe my channel to get the latest updated video. And believe in yourself and you will be able to succeed. Thank you so much.